Hi guys, it's nice to see you again today. You're welcome to our class for today. If this is your first time of being here, please kindly like, share, and subscribe. My name is Khan Maudis and I'm your math tutor. We are still looking at functions. Today we'll be looking at inverse functions. That's what we'll be looking at today. Inverse function. How to find inverse of a function. How do you find inverse of a function? So let's get right into it. Inverse functions. So what do we mean by inverse function? Now, if I'm given a function f of x, let's say I have a function f of x. The inverse of this function f of x is written as f to the power minus 1 of x. So this is how you write the inverse. If my function, I have a function f of x, then the inverse is written this way. This is called f inverse of what? X. And what does it mean? What it means is that this particular function here, the inverse, reverses the process of this function. So the job of the inverse of a function is to reverse the process of the main function. That is the job of an inverse, of the inverse of the function, is to reverse the process of the function itself. So if, for example, I have a function, let's say this is I have my domain, I have my range, this is my function f. Now this function assigns elements from this set, which is our input set, to this set, which is our range, or output set. Now what is the job of the inverse function? The inverse function now, the job of the inverse function is now to assign elements from the set y here to the set x. So the set y will now become the input element of the inverse function, while set x will now become the output set. Set y will be the input set, while set y will be the output set for the inverse. But for the main function, this is the input set, this is the output set. So this is the domain, this is the range. While for the inverse function, this is now the domain and this is the inverse. So you see how it works out. So we can see that for an inverse element, the domain of f inverse of x is the range of f of x. The domain of the inverse is the range of the main function. And if you notice what I told you, that we can find the range of the function if we can play around with the inverse. So if you find the domain of your inverse function, the domain of your inverse function is the range of the main function. Are we together? Then another thing is that the range of the inverse function, the domain of f inverse of x, is the range of f inverse of x is the domain of f of x. That is it. So you have this. This is your function, this is the inverse, this is how it is written. And I told you that what the inverse does is to what? Reverse the process of the main function. Are we together? Now there are some things you need to take note about inverse function. Number one, not all functions have inverses. Not all functions have inverse. Not all functions have inverse. Number two, for you to find the inverse of a function, that function must be one-to-one and onto. To find the inverse of a function, the function must be one-to-one and onto. And a function that is one-to-one and onto is called what? If you still recall, when we did types of function, it's called a bijective function. So for you to find the inverse of a function, that function must be bijective. Bijective meaning it is one-to-one and is also onto. Are we together? Now, the next thing about inverse function is that if we can find the inverse of a function, it will enable us to find the range of the main function. If we find the inverse of the function, we can easily find the range of the main function. That is, That is the 3 points that you need to take note about inverse function. Now the next thing is, to find the inverse of a function, there are some series of steps we need to take note of. There are about 3 steps. Although, let me put this, the second step is not a compulsory step. The second step is not compulsory, but there are 3 steps that we can use to find the inverse of a function. What are the 3 steps? The first step, step 1. Step 1 is rewrite f of x as y. The first step is rewrite f of x as y. So instead of using f of x, you use y. And you're going to see why we use y instead of f of x at the end of the day. Then step 2. Now this step is not a compulsory step. You can skip this step if you don't want to. So for step 2, swap x and y. Swap x and y. So if I rewrite f of x to be y, so for example, let's say I have my function f of x equals to 3x. This is my function. The first step says rewrite f of x as y, meaning that I will say let y be equals to what? F of x. If I say let y be equals to f of x, instead of using f of x, I can say y equals to what? 3x. Y equals to 3x. So I'm not using f of x again. That is what step 1 is telling you. Rewrite f of x as y. That is it. So instead of using f of x, we use y. Now what does step 2 says? Step 2 says swap. Now take note, this is optional. Let me put this. It's optional. So swapping means I will exchange. Instead of y, I'll change this y to x. Then I'll change this x here to what? Y. That's what we mean by swapping. So you change your x, you change your y to x, change your x to what? Y. That's the swapping. Then step 3. Step 3. This step 3 can be step 2. But this step 3, depending on what you do in step 2, if you had taken step 2, then step 3 will be make y subject of the equation or subject of formula. I'll just say subject of the equation. Okay, let me write it in. Make y subject of the equation. Make y subject of the equation. That's step 3. But now, if you did not swap x and y, if you did not swap this step 2, if you did not observe step 2, that's if you did not swap x and y, what you are to make subject of the equation is what? X. If you did not swap x and y, that is step 2, then what you are to make subject of the equation is what? X, not y. But if you have swapped x and y, then you are to make y subject of the equation. So please take note of that. This step 3 is only done if you swap x and y. But if you don't swap x and y, you have to make x subject of the equation. Are we together? So from here now, I'll make my y subject of the equation. How do I make y subject of the equation? Subject of the equation means just make y to stand on its own. Make y to stand alone. How do I make y stand alone? So from here, I have x equals to 3y. To make y stand alone, I will divide both sides by the coefficient of what? Of y, which is 3. So if I divide both sides by the coefficient of y, x divided by 3 equals 3y all over 3. 3 and 3 will go. Y will stand on its own, and y will be equal to x all over 3. X all over 3. Then finally, this y now, this y will be subject of the equation. We now rewrite it as what? F inverse of x equals to x all over 3. So let's put that as step 4. Step 4. Rewrite y, that's the y, after making it subject of formula, rewrite y as f inverse of x. That's it. So this is the inverse of this function. So if I have a function f inverse of x equals 3x, f of x equals to 3x, then f inverse of x is what? X all over 3. So this function here we will reverse the process of this function. And we can actually prove that. So let's say for this function, let's say we have, let me say I have my input value and I have my output value. So let's say my input value I have 0, 1, minus 2. Now, for this particular function now, my function is f of x. So if x is equals to 0, my f of x, that is f of 0, will be 3 times 0. And 3 times 0 is what? 0. So this is 0. If my x is equals to 1, this implies that f of 1 is equals to 3 times 1, and 3 times 1 is what? 3. If my x is equals to minus 2, this implies that f of minus 2 is equals to 3 times minus 2. This will give me minus 6. So this will be 3, and this will be what? Minus 6. So for this input value, this is what you have here as your output for this particular function. Now remember, the job of the inverse is to take this output and get back this input. So the job of the inverse is to reverse the process of the function, meaning that it will take this as its input and give you this as its output. So let's check and see. For the inverse, if my x is equals to 0, this implies that f inverse of 0 will be, that will be 0 divided by 3. 0 divided by 3 is 0. So we have 0 back. Now, if we pick 3, if x is equals to 3, this implies that f inverse of 3, we are picking 3 now, as the input for the inverse function. This will be 3 divided by 3. 3 divided by 3 is what? 1. So we get 1 back. Now, if we pick minus 6, if x is equals to minus 6, it implies that f inverse of minus 6 will give me minus 6 divided by 3. Minus 6 divided by 3 is what? Minus 2. So we get minus 2 back. So you see that the work of the inverse from here, this is our inverse. The work of the inverse is, we have a function f defined on the set of real numbers as f of x equals to 3x plus 4 all over x minus 1, where x is not equal to 1. So what you are trying to do here is, this is defined on the set of real numbers. So it means that all real numbers are supposed to be a domain, but now they are making sure that we don't make the mistake of saying all real numbers is the domain, because if x is 1, then this function is not defined, meaning that not all real numbers. We can say it's all real numbers excluding 1. So 1 is not part of this, the domain of this function. That is why you have this x minus 1 here, meaning that 1 is not part of the domain. Now, after defining the function for us, we are now told to find A, the inverse of the function, B, the range of the function, the inverse of the function, the range of the original function. So after finding our inverse, it will be easier for me to find the range. Then, of course, we now have f inverse of f of x. This is composition of the inverse and the main function. That's what we have to do at the end of the day. So now, let's take the solution. Let's start from here. Let's take the solution. Now, we are finding the inverse first, inverse of the function. Now, to find the inverse of this function, now, our function f of x is equals to 3x plus 4 all over x minus 1. That's the function. And we have to find the inverse of this function. Now, what was the first step to finding the inverse of the function? The first step was we should rewrite f of x as y. So we'll say let y be equal to f of x, meaning that we can write this as, instead of putting f of x, we write y equals to 3x plus 4 all over x minus 1. Now the question is, why do we rewrite f of x as y? Why do we take that step? It is because what we are going to be doing here to find inverse is actually change of subject of formula. And in changing the subject of formula, if we use f of x as it is here, it will be a little bit cumbersome to play around with it when we are changing subject of formula. So in order to make it easier for us in changing the subject of formula, so that is why we use y instead of f of x. So y is easier for me to play around with when changing subject of formula. So that's why one of the prerequisites to finding inverse of a function is knowing how to change subject of formula. So if you don't know how to change subject of formula, it might be a little bit stressful for you, but it's easier if you follow through what we are going to be doing. If you don't know how to change subject of formula, you can put it in the comment section so that I'll make video about that, so that you will understand more about changing of subject of formula. So what we are going to be doing here is simply about changing of subject of formula. So rewriting y as f of x makes our work easier instead of using f of x to change the subject of formula. So after doing this, what was the second step? The second step was swapping x and y. That was the second step, swap x and y. So can we swap x and y? What it means to swap x and y means this y here, I'm going to change it to x, and the x here, I'll change it to y, all over, I'll change this other one to y. Are we together? So that is the second step, swapping x and y. But take note, we say that this step is not composing. This step here is not composing. So you can still leave it this way and continue. So if you are leaving it this way, you want to continue from here without coming to this step. What you have to do is, from here, make x subject of formula. But if you take this second step, what we have to do now is, step 3 is, make y the subject of the equation. That's what we have to do. How do you make y subject of the equation? So what we do is, this is, on the right hand side you have a fraction, on the left hand side you have a single term. So what we have to do is, we have to rewrite this left hand side as a fraction as well. So I'm going to write it as x all over 1 equals to, what I have here is 3y plus 4 all over y minus 1. So this is what I have now. Now from here, what do I now do? I'll cross multiply. That was the essence of writing the two sides as fraction. The left hand side the fraction, the right hand side the fraction, so that I can cross multiply. If I cross multiply now, so let me write it there, cross multiply. If I cross multiply, I'll have x times y minus 1. How do I write that? X times y minus 1. This is the proper way of writing it. Not this, x times y minus 1. No, this is wrong. This is the proper way of writing it. Why? Because y minus 1, what you have here in the denominator here, is an expression. You have more than one term. You have two terms here, y and minus 1. So since you have more than one term, the proper way of writing this x times y minus 1 is, the single term here is outside the bracket, then this is inside the bracket. That's the proper way of writing it. If you are multiplying a single term with an expression, the expressions will be inside the bracket. So that's why we have this x times y minus 1. Now this will be equal to, now 1 times 3y plus 4. 1 times 3y plus 4. Now with respect to multiplication, you should know that 1 is the identity number or identity element with respect to multiplication, meaning that anything you multiply by 1 gives you the same thing. So if you multiply anything by 1, it gives you the same thing. So for example, 2 times 1 will give you 2. 5 times 1 will give you 5. 8 times 1 will give you 8. 100 times 1 will give you 100. So anything you multiply to 1 will give you the same thing because 1 is an identity number. So even if I multiply 8 times 1, 8 times 1 is what? 8. So in this case now, 3y plus 4 times 1, or 1 times 3y plus 4, is the same as what? 3y plus 4. We are going to get the same thing. So this will give us 3y plus 4. Now let me erase this. Now from here, what do we do now? We have to expand this bracket. That's the next thing to do. We expand this bracket. Make sure there is no bracket. So if we expand this, we are using the x outside here to multiply the terms inside. That's what we mean by expanding. So x times y is what? Xy minus x times 1 is what? X equals to 3y plus 4. That's the next thing to do. We have this. Now from here, what's the next thing to do? We have to make y subject of the equation. Don't forget. So making y subject of the equation now means if I have y here and I have y here, how do I make the subject of the equation? Do I make this y subject of the equation or do I make this y subject of the equation? The proper thing to do is this y and this y here, I must bring them to one side of the equation. So I'll look for any term that has y, put it on one side of the equation, and any term that does not have y, we take it to the other side of the equation. That is what we have to do. So this term has y, we'll keep it here. This one that also has y, we'll move it to this other side. Then this one that does not have y, we'll move it to this other side. Then in doing that, I'll have xy, this 3y here. Because it's positive, when it crosses the equality sign, it will become negative. But the proper thing to do is using the multiplicative inverse. But we don't want to waste time doing that. So this 3y here, it will cross the equality sign. Since it's positive here, it will become negative 3y equals to, I have 4 here, then this minus x, when it crosses the equality sign, since it's negative here, it will turn what? Positive. So that's what we have. Now from here, you notice that I have my y here, I have my y here. So I have two terms with y on the two of them. So what do I now do? From here, what we have to do is what? Collecting of like terms. What we have to do now is factorization. Factor out what they have in common. So they have y in common, we'll factor it out. So if I factor y out, I'll have x minus 3 equals to 4 plus x. This is what I have. So this y now is factored out from here. Then you have x minus 3 inside the bracket. This x minus 3 will be treated as a single term now. You're not going to treat it as two terms. You're treating it as a single term since it's inside the bracket. So it's like saying y times a single letter. Let's say a. So if I have y times a equals to 4 plus x, if I want to make y stand alone, what do I do? I will divide both sides by what? A. I will divide both sides by a. So if I divide both sides by a, my y will be equal to what? 4 plus x all over what? A. Are we together? So this x minus 3 will be treated as a single term like a. That's what we have to do. So what I will now do is I will divide both sides by x minus 3. Divide both sides by x minus 3. This will give us y x minus 3 divided by x minus 3 equals to 4 plus x all over x minus 3. So x minus 3 will cancel x minus 3. If that is so, y will be equal to 4 plus x all over x minus 3. So that's it. We have that. That is our y. We've made y subject of the equation from here. Then the last step now of finding our inverse is what? Well, once you make your y subject of the equation, rewrite y as what? F inverse of x. So this will now be f inverse of x is equal to 4 plus x all over x minus 3. So that's the solution to A. Now let's move to B. B. Find the range of f of x. Now, recall what I said when we were talking about inverse. We said that if you are to find the inverse of a function, the domain of the inverse is automatically what? The range of your main function. Look at this. I have my domain here. I have my range here. This is for my function. This is my domain, this is my range. Now, the inverse of this function, if I take the inverse of the function, this will now be my domain for the inverse, and this is my range for the inverse. So this is the domain for the inverse. Now this domain of my inverse function is actually the range of my main function. So if I'm told to find the range of my function, if I find the domain of my inverse, then that means automatically I found the range of my function. That is how easy it is. If I find the domain of my function, of my inverse function, that automatically means I found the range of my main function. So now, let's now look at how do you find the domain of a function. We've done that before. How to find the domain of a function. What did we say we do? When you have a rational function and you want to find the domain, we say find the number that will make this particular function to be undefined. Meaning that since it's a rational function, what is the number that will make the denominator to be 0? If you find the number that will make the denominator to be 0 and you get the number, exclude that number from the set of real numbers and you've gotten your domain. Are we together? Because the domain of a function in this case is supposed to be the entire set of real numbers. But since it's a rational function, we have to find what is the number that will make my denominator to be 0. We find that number and exclude it from the entire set of real numbers. So what we have to do now is pick the denominator, x minus 3. My denominator is x minus 3. I'll take that denominator, equate it to 0. I want to find the value of x that will make that denominator to be 0. So I'll equate it to 0. We add the additive inverse of minus 3 to both sides. What's the additive inverse of minus 3? The additive inverse of minus 3 is what? Plus 3. That is a number that you add to minus 3 to make it 0. Because we want to make x stand on its own. So I'll have x minus 3 plus 3 equals to 0 plus 3. Now from here I'll have x minus 3 plus 3. Minus 3 plus 3 is what? 0. So this will give me x equals to 0 plus 3 is what? 3. So the number that will make my denominator to be 0 is what? 3. So what do I now do? I'll exclude 3 from the set of real numbers to get my range, which is the domain of my what? My main function. So I can say that the range of f of x is equals to x such that x belongs to the set of real numbers and x is not equal to 3, meaning that 3 is not part of the real numbers. It's not part of the numbers. 3 is excluded. So this is the range of my function, which is what? The domain of my inverse. This particular range is what? The domain of f inverse of x. This range is the domain of f inverse of x. That is it. It's as simple as that to find the range of the function. Now, C. What are we doing in C? C says f inverse of f of x. That is composition of function. Composition of function. So this will be f inverse of f of x. If we write it this way, we write it this way, meaning that our f of x will be the input element of what? Our inverse function. The input element of our inverse function is now what? F of x. So what we now do is we say f inverse of what? What is f of x? Our original function. That is 3x plus 4 all over x minus 1. 3x plus 4 all over x minus 1. So this is our input element now. This is what we are inputting into our inverse function now. So when x was the input element, what do you have? 4 plus x all over x minus 3. Now that this is our input element, what are we going to get? So this will give us 4 plus, instead of x there, we are going to have this input value. That is 3x plus 4 all over x minus 1 all over. Now we now go to the denominator. Instead of having x there as our input, this will be our input. That is 3x plus 4 all over x minus 1, then minus 3. So this is what we have now. This is what we have now. Now, what do we do from here? Do we leave it like this? No, we cannot leave it like this. We have to resolve it to a single fraction. Because if you look at in the numerator here, you have a whole number and you have a fraction here. Here you have a fraction and you have a whole number here. So we need to resolve it to make it a single fraction, where you have only numerator and denominator, not this kind of case. So what do we now do? We have to start planning now with it. Since I have the question here, I will leave this and clean this part of the board. So what I'm to do now is, I have to resolve this numerator, resolve everything here to make it a single fraction, and resolve this denominator here to also make it a single fraction. That's what I'm to do. So this will give me, now, this 4 here can be written as 4 over 1. So that the denominator here will be 1, the denominator here is x minus 1. And you recall that if you are adding two fractions in which the denominators are not the same, what do? You find the LCM to be able to play around with it. So the LCM of 1 and x minus 1 will give us what? That will give us x minus 1. Now, x minus 1 divided by 1, let's say this is over 1. Let me put this here, over 1. So x minus 1 here, divided by 1 here, is x minus 1. X minus 1 times 4 will give me 4x minus 1, then plus x minus 1 divided by x minus 1, that's 1. 1 times 3x plus 4 will give me 3x plus 4. All over, we now come here. I have this and this. Now this 3 here can be written as 3 over 1. So that my denominator here is x minus 1 and my denominator here is 1. The LCM of x minus 1 and 1 is also x minus 1. So now we have x minus 1 divided by x minus 1 is 1. 1 times 3x plus 4 will give us 3x plus 4. Then minus x minus 1 divided by 1 is x minus 1. X minus 1 times 3 will give us 3x minus 1. 3 times x minus 1 inside the bracket. Why did we say we are doing it this way? Because x minus 1 is an expression, it's not a single term, so you have to put it inside the bracket. So from here we are going to have, we have to expand the numerator of this numerator. That will give us 4 times x, that is 4x, then 4 times minus 1 minus 4 plus 3x plus 4 all over x minus 1. Then we come down here, we use this minus 3 to expand. We'll have 3x plus 4, then minus 3x times x will give us minus 3x, then minus 3 times minus 1 will give us plus 3 all over x minus 1. That's what we have. Now from here, what do we do next? This will give us, we resolve the numerator of our numerator. So we have 4x plus 3x, that will give us 7x. Then minus 4 plus 4. Minus 4 plus 4, that's 0. So this and this will go. Minus 4 plus 4, 0. So we have 7x all over x minus 1. All over. Now we come here to the denominator. 3x minus 3x. 3x minus 3x, that's 0. So they will cancel out. Now 4 plus 3. 4 plus 3 is 7. So that's 7 all over x minus 1. So now we have a single fraction in my numerator, a single fraction in my denominator. Do we leave it like this? No, we still have to resolve it to make it a fraction now. So because this means this fraction divided by this fraction. And how do you play around with division of fractions? So I'm going to write this as 7x divided by x minus 1 divided by this division here. This is how I'm writing it now. Divided by 7 all over x minus 1. So in solving problems involving division of fractions, we have to use this concept KCF, which means keep, change, flip. Keep, change, flip. What that means is that keep the first fraction change your operation from division to multiplication, then flip the second fraction. Flipping the second fraction means take the numerator down and take the denominator up. So you flip it. That's what we want to do next. This will give us 7x all over x minus 1 times x minus 1 all over 7. Now, x minus 1 can cancel x minus 1. X minus 1 is the denominator here, x minus 1 is the numerator here, you can cancel out. Now, we now have 7x here and we have 7 here. The 7 here and the 7 here can cancel out because they are just single terms. So, this 7 here and this 7 here can cancel. So, what are we left with? At the end of the day, we are just left with what? X. At the end of the day. X is what we are left with. So, we can now say that f inverse of f of x is equals to what? X. So f inverse of f of x is equals to x. Now, I would like you on your own to do this. Can you find f of f inverse of x? Find that and check if it will be equal to x. Because if you still recall, in our last video, we said that composition of functions is not commutative. Composition of functions is not commutative. So if f inverse of f of x gives us x, what will f of f inverse of x gives us? So you check it and see if it is commutative or not. So we would like to stop the video here. In our next video, we'll be looking at modulus function. Modulus function. So make sure you subscribe, like, and share this video. And also put your comment in the comment section there. If you like us to do video on any topics, even though it's not related to this, anything you have problems with, you want me to do video on it, please put it there in the comment section and I'll do that. So thank you very much for Thank you very much. We'll see you in the next video. Keep it neat.